In this video, we're going to be talking about how we can rationalize a denominator. Now, rationalizing the denominator is something that you would normally do at the end of whatever problem you're solving. So if you carry out some sort of procedure to solve a problem, and then your answer has roots on the bottom of it, some teachers will tack off points if you don't get rid of the roots on the bottom, and rationalizing the denominator is how you do that. So that's what I'm going to show you in this tutorial today. So let's say that I had 3 over 4 times the square root of 3. So the whole idea of getting rid of the roots in the bottom is to multiply the root by something that's going to get rid of it. So if we have the square root of 3 and we multiply it by the square root of 3, this gives me the square root of 3 squared. And as we know from our properties about radicals that are in the previous video, I know that the second degree exponent and the square root cancel each other, so I'm just left with 3. So what I'm going to do is I'm going to take this number and I'm going to multiply top and bottom by the square root of 3. And this is legal to do because the square root of 3 over the square root of 3 is just 1, and 1 multiplied by anything just returns the same thing. That's the identity property. So when I carry out this operation, I end up with a 3 square root of 3 on the top and a 4 times the square root of 3 squared on the bottom, which we've shown over here is just the number 3. So we have 4 times 3 on the bottom. The 3's on top and bottom end up canceling out, so we're able to simplify this a bit further. And then I end up with the square root of 3 on the top and a 4 on the bottom. And this is the simplified version. So notice how in doing this, when I multiply top and bottom by the square root of 3, I get rid of the square root of 3 that was on the bottom originally. And that's what it means to rationalize the denominator, is to get rid of the roots in the denominator. So let's say I had 12. Oh, whoops, that's the wrong color. Let's say that I had 12 over the cube root of 4. So the same idea is true for the cube root. We want to multiply the denominator by something that's going to get rid of the cube root. So if I multiply this by the cube root of 4 squared, this is the same as me writing the cube root of 4 times the cube root of 4 squared. And in essence, what this is the cube root of 4 raised to the first power times the cube root of 4 raised to the second power. So remember, if we have the same base and we want to multiply them but they have different exponents, this is the same as adding, you're going to have the same base, but the exponents are going to be added together. So this comes out to the cube root of 4 raised to the third power because we add the two exponents. And then on the properties that we learned about radicals, a cubic power and a cubic root cancel each other. So we're just left with the number 4. So when I utilize this property, what I'm going to do is I'm going to have 12 on the top times the cube root of 4, and then I'm going to multiply that top and bottom by the cube root of 4 squared. And what this is going to do, it's going to give me 12 times the cube root of 4 squared on the top. And from what I just shown you over to the right, the bottom is just going to be the number 4. 12 over 4 reduces to 3. So what I'm left with is 3 times the cube root of 4 squared. And I can rewrite the inside of this to be 3 times the cube root of 8 times 2. Because 4 squared is 16, and 16 can be rewritten as 8 times 2. So what I have is I have 3 times the cube root of 8 times the cube root of 2. And the cube root of 8 reduces down to just the number 2. So this is the same as 3 times 2 times the cube root of 2. And this simplifies down to 6 times the cube root of 2. Now let's say I had two terms in the denominator. Let's say I had 1 over 2 minus the square root of 3. So in this case, we have to think outside the box for a little bit. So remember the discussion about conjugates. So the conjugate of 2 minus the square root of 3 is 2 plus the square root of 3. So in a conjugate, you have the same numbers, except you switch the signs. So look at what happens when we multiply top and bottom by the conjugate of the denominator. So that's going to be 2 plus the square root of 3 divided by 2 plus the square root of 3. And again, this is legal to do because 2 plus the square root of 3 divided by itself just gives me the number 1. And when you multiply this fraction by 1, you just get the original fraction. So on the top, I'm going to have 2 plus the square root of 3. And on the bottom, I have a FOIL method to do. And this is going to come out to 4 minus 3. And I'll just show you over here. So if I multiply the conjugates together, this is going to be a FOIL method. So the first product is 4. Outside product is plus 2 times the square root of 3. Inner product is minus 2 times the square root of 3. You can see that these cancel each other. And then the last product is minus square root of 3 times square root of 3, which gives me a minus 3. So what I'm left with is 4 minus 3. And 4 minus 3 just gives me a 1. And when I divide 2 plus the square root of 3 by 1, I'm just left with 2 plus the square root of 3. So not only do we get rid of the square root in the denominator, we don't have a denominator at all whenever we rationalize it this time. So it's even simpler to look at. Let's do another example of that. So let's say I had 1 over the square root of 5 plus 1. So again, I'm going to multiply top and bottom by the conjugate of the denominator. And in this case, it's going to be the square root of 5 minus 1. When I do that, I end up with a square root of 5 minus 1 on the top, divided by a 5 minus 1 on the bottom. 5 minus 1 is just 4. So what I end up with is a square root of 5 minus 1 divided by 4. And we've effectively moved the root out of the denominator by doing this. I hope this video was helpful about learning how to rationalize denominators. Again, this is typically something that you do at the end of a problem whenever you have a root for your answer in the denominator. And if your teacher tacks off points for not simplifying it completely, then this is what needs to be done. And if you have some sort of calculus class, there's a lot of use for rationalizing the denominator, because if you have to do it in the middle of some sort of procedure that you're doing to solve a more complicated equation, it can make the math a lot easier. So I hope this video was helpful. Thanks for watching, and I will see you for the next one.